Section 22.22 Oxidative Addition and Reductive Elimination. First, let's look at oxidative addition. Oxidative means the oxidation number of the transition metal increases. Addition means ligands are added to the transition metal. For example, in this reaction, the number of ligands increases from 4 to 6. We have 2 more ligands in this complex, methyl, addito. Now let's look at the oxidation number of platinum. It's 2 in the reactant and 4 in the product. So the oxidation number of this transition metal center also increases. Now let's do some electron counting. We'll have to assume this 2 sigma bonding electrons go to the ligand, and therefore we have this neutral ligand. These 2 electrons go to this methyl, go to the carbon in the CH3. That makes this methyl group negatively charged. We have CH3 minus here and CH3 minus here. Therefore, we have -1 charge on each of these 2 methyl ligands. Therefore, this PT must have an oxidation number of +2. Over here, other than these 2 methyl ligands, there's a third methyl ligand that bears a negative charge. This addito ligand also bears a negative charge. Therefore, the oxidation number of platinum is +4. So the oxidation number increases from 2 to 4. And it just happens that when we add ligands to the transition metal, very often it's accompanied by the increase of the oxidation number of the transition metal. It's not always true. Sometimes there's just no change, but very often these 2 happen together. Now, reductive elimination. In this kind of reaction, the oxidation number of the transition metal decreases. Thus, it's reductive, while ligands are eliminated from the complex. For example, in this reaction, the number of ligands decreases from 6 to 4. Now let's look at the oxidation number of platinum. You have a -1 charge on this hydride, addito, methyl, and this methyl. These 2 triethylphosphino ligands are both neutral. Therefore, we have a total of 4 negative charges on the ligands. This platinum then must have an oxidation number of +4. In this structure, you have a negative charge on iodine, another negative charge on this methyl ligand. Therefore, the oxidation number of platinum is 2. We are looking at the elimination of 2 ligands, so this ligand and this ligand. And also, we observe the decrease of the oxidation number of the transition metal center from 4 to 2. Now I'm going to give you another example. It's a catalytic cycle for the hydrogenation of ethane. And this is Wilkinson's catalyst. So you put this catalyst in a solvent. A solvent molecule can replace one of these 2 triphenylphosphino ligands. There are 3 of them. So it's going to replace one of the 3. So we have a solvent here, a chloride here, and then we have these 2. Both are triphenylphosphino ligand. And then hydrogen comes in. This is dihydrogen molecule. So now this rhodium gets 2 more ligands. So it's going to be addition. And also, if you look at the oxidation number of this rhodium, it increases from 1 to 3. So again, this is not sulfur. This is a solvent molecule. You may consider this as a neutral solvent molecule. And you have 1 negative charge on here. So this rhodium has an oxidation number of 1. But now over here, you have 2 more ligands, and you have this H minus and this H minus, both hydrido ligands. There's another minus charge on chlorine. Therefore, in this complex, this is rhodium 3. So the oxidation number increases from 1 to 3. And this step is oxidative addition. So we can go from here to here. This ethane or ethylene replaces the solvent over here. And then we have migrative insertion. We'll talk about this step later in another video. Let's focus on this reductive elimination. So over here, you still have rhodium 3. You have a negative charge on this hydrogen, a negative charge on this carbon, a negative charge on this chlorine. So this rhodium has an oxidation number of 3. And then this is reductive elimination. This hydrogen and this ethyl ligand leave at the same time and form this ethane. Now let's look at this structure. Again, this is rhodium 1. This is rhodium 3. From 3 to 1, it's reductive. And also 2 ligands are eliminated simultaneously from this complex. And therefore, this step is reductive elimination. This step is oxidative addition.